This video is about proportionality in graphs. The essential question is, how can you tell if two quantities have a proportional relationship in a graph? So let's kind of backtrack just a little bit. We've already talked about proportionality in tables, so how do you know if two quantities are proportional in a table? Well, you should be able to multiply the x value by the same number each time to get the y value. That's what would make it proportional. Remember, the x value is the independent variable. So you can multiply that x value, the independent variable, by the same number, which would be the unit rate. Each time to get that y value. And remember that y value is the dependent variable. Okay. So kind of off to the side here, here's a little visual for those of you that are more of a visual learner. So you have your x value here, and when you go y divided by x, you get that number, which would be the unit rate. So you had your x value right here, and you multiply it by that unit rate, and you get the y value. And you multiply that by this x value by the exact same number, the unit rate, to get the y value. Multiply this x value by the same exact unit rate to get this corresponding y value. And so on and so forth. Okay? That's what makes a table proportional. Okay, so let's start by analyzing the ordered pairs in this particular table right here. It's already labeled as x and y, so right now we're going to go ahead and find the unit rate. So I'm just going to take this y value and divide it by the x value, similar to what we've always done. So y divided by x. So 1 divided by 3 is that. And 0.3 repeating, that's 1/3, okay? When you go 1 divided by 3, it's the same thing. So basically we're timesing by 0.3 through the repeating, or more precisely without rounding, more precise than rounding is writing times 1/3. Okay, 2 divided by 6, same thing. 3 divided by 9, same unit rate. 4 divided by 12, same thing. Okay. So something I want you to know is 0.3 repeating is equal to 1/3, okay? So when I went y divided by x, y was 1, x is 3, 1/3. You can keep it a fraction. 2 divided by 6, because that's y divided by x. Well, that simplifies to 1/3. 3 divided by 9, that also simplifies down to 1/3, because divided by 3 divided by 3. 4 divided by 12 is also 1/3. So instead of writing times 0.3 repeating, you could also write one-third. Okay. All right, so we know that this is a proportional table, so we can answer this question. Yes, because there exists a constant of proportionality, and that's just a fancy word for unit rate. So something that you ought to know is if the table shows a proportional relationship, then so will the graph of the coordinates within the table. Okay? So now we're going to go ahead and plot these ordered pairs onto this table. Okay? So your first ordered pair, like when you plot points, this is really 3, 1. That's what you would think of. So x is 3, y is 1. There's your first ordered pair. The next ordered pair is 6, 2. I'm going to write this to the side so that you can kind of see it. So these are the coordinates, or points. So this is 3, 1, 6, 2, because this is a format that you're more familiar with the work we've done in class. You've seen ordered pairs like this. Okay, so 3, 1, 6, 2, x is 6, y is 2, x is 9, y is 3, x is 12, y is 4. Okay. So look at this graph right here, and I want you to connect those points and just extend them as far as they'll go. And it helps if you have a straight edge, okay? And maybe 2 hands available. So some of you might connect it like, oops. Some of you might just connect it like that, just the points. But I do want you to extend it. Oh, crud, sorry. I'm trying to hold the ruler with my elbow, because I'm holding the camera with my left hand. Okay. This is kind of a funny look for me. Okay, so see how I extended it right there? And it's important that you do that, even if the points, you only see the points right there. Don't just connect the points. I want you to extend it, because a characteristic of a proportional graph, one of the characteristics, is it will go through the origin. Okay, so if you just stopped it right there, you want to extend it to see, hey, does it go through 0, 0, which is the origin. Okay? So like I said, if the table shows proportional relationship, then so will its graph. So right here, folks, we have a proportional graph, and just pretend I went through that dot, okay? Just it's supposed to look like that. So let's go ahead and answer this question for your summary. Since you now know that the graph above is proportional, describe how it looks. What are the characteristics that make it proportional? All right, so here are the characteristics that make this graph proportional, which you can write in your summary. It is linear. Linear means it's a straight line. And it passes through the origin, the point 0, 0. Those two characteristics make a graph proportional. The next example wants to know, is the money received proportional to the number of candy bars sold? So we'll go ahead and start with looking at the table, and then we'll examine the graph, okay? So I see that the x independent variable column and the y dependent variable column are already labeled, so that really helps me. Now I'm going to go ahead and see if there's a unit rate that exists between the relationships in this graph, okay? So I'm going to go y divided by x, so 3 divided by 2. Oops. And that's 1.5, so I multiplied this x value by 1 5/10, or 1.5. Now 5/4, 5 divided by 4. And I got 1 25/100. And 9 divided by 8. Because it's a y divided by x. 1 125,000ths. 12 divided by 12, that is 1. Oops, sorry. 12 divided by 12. Oh gosh. 1. Okay, so you'll see right here that there are different rates that exist right here, and therefore this is not a proportional graph. So is money received proportional to the number of candy bars sold? No. There is no constant ratio. Constant ratio is the same as unit rate, which is the same as constant proportionality, okay? There's no constant ratio between the money received and the candy bar sold. So, since this table is not proportional, we know that this graph will not be proportional, okay? So we're going to examine the characteristics that make this graph not proportional. So those points or coordinates, I'm going to write them over here. That's coordinates, 2, 3, x and then y. 8, 9, 12, 12. So we're going to go ahead and plot these ordered pairs onto our graph. 2, 3, x is 2, y is 3, 4, 5, x is 4, y is 5, 8, 9, x is 8, y is 9, 12, 12, x is 12, y is 12. Okay, it does not appear that this is linear. Yeah, so see how it's kind of off a little bit like that? Okay, so this graph right here, it's not linear. You could say non-linear. And does not pass through the origin. Another word for origin is 0, 0, okay? So this is not proportional, okay? Because for a graph to be proportional, it's got to be linear and pass through the origin. It's got to be both of those. We can still understand this graph, though, what it means. So it says, what does the point 8, 9 mean? So x is 8, so that means when you buy 8 candy bars, it will cost, or you will get $9, okay? Or you could say $9 was received for 8 candy bars. All right, and the next example it asks, is y proportional to x? So again, we're going to do y divided by x to see if a constant proportionality exists. And of course, we're going to plot these ordered pairs from the table onto this graph. So I'm going to just list the points. You can say points or coordinates. 0, 0, 3, 1 and 1/2, or 3 and 1.5, 14, 7, 9, 4.5, 11, 5.5. Okay, let's go ahead and do y divided by x. Now you want to skip 0 divided by 0 because that's just not going to work. So let's go 1.5 divided by 3. And if you're curious how to make 1.5 into a decimal, it's just 1.5 divided by 3. So that 1.5 divided by 3. Okay, 5/10. Multiply this by 5/10. 7 divided by 14. And then 4.5 divided by 9. 5.5 divided by 11. Okay, so our unit rate is 0.5 or 5/10, or 1/2. That all equals each other. So this is proportional. Yes, yes, it's proportional because the unit rate is 1/2 or 0.5. Okay. All right, so since we know that this is a proportional table, let's go ahead and examine what it would look like on the graph. So 0, 0, 3, 1 and 5/10. So 3, 1 and 5/10. So here's 3, x is 3, y is 1 and 5/10, or 1.5, which is right in between the 1 and the 2. 14, 7. 9, 4.5. 9, 4.5. 11, 5.5. ahead and connect those ordered pairs. Okay, so you'll see right here that it's linear. Which means it's a straight line. And passes through the origin, passes through 0, 0. Which is the origin. And that's what makes this graph proportional. Yay! Okay, which point is the unit rate? Well, when x is 1, the corresponding y value will be the unit rate. So when I look up here, I can't exactly tell what that is because my graph could also be a little bit off with my elbow holding of the ruler. So I'm going to go ahead, just to be safe, I'm going to plug it into the table. So I know when x is 1, the corresponding y value will be the unit rate. So I'm going to multiply this by 5/10. So 1 times 5/10 is 5/10, or 1/2, same thing. So the ordered pair for the unit rate is 1, 1/2, or 1, 5/10. This right here, this point represents the unit rate. That's represents, okay? So 1, 1/2, which means when x is 1, y is 1/2. Why is this graph proportional? Well, it looks like I already answered that right here. Okay, so what makes this graph proportional is it's got to be linear and pass through the origin. If it was only linear and didn't pass through the origin, that's not proportional. If it only passed through the origin and it wasn't linear, then it's not proportional. It's got to be both, okay? Now for more practice, this example also asks, is y proportional to x? You got your columns already labeled right here, your independent variable column, your dependent variable column. And all you gotta do is, let's see if there is a unit rate that exists between the relationships expressed in this graph right here, okay? So let's go ahead and find the unit rate, y divided by x. So 4 divided by 1, that's 4. I guess I'll do this right here just to show you the process. So multiply that by 4. 5 divided by 2, because it's a y divided by x. So 5 divided by 2. 2.5. 6 divided by 3, which is 2. 7 divided by 4, y divided by x. Sorry, I pressed the wrong button. So 1 75/100. Okay, so you'll see there that there's no unit rate. It's not proportional. So let's go ahead and see what the graph would look like. This is a non-proportional graph because the table is not proportional. And remember, our ordered pair, our points are 1, 4, 2, 5, 3, 6, 4, 7. Okay, let's go ahead and connect the points, please. Hey, look, it's linear, but it's not proportional because it does not go through the origin. So still not proportional, even though the graph is linear. Linear means it makes a straight line. It does not pass pass through the origin, or 0, 0. So it's not proportional. Okay. All right, I do want to show you something that can help you in the future. Whenever you have a linear graph, you're able to find something called slope. And similar to a ski slope, it kind of tells you how steep a line is, okay? So like how steep a hill or a mountainside would be, which would be your slope. You can find slope on this, okay? So I'm just going to teach you that real quick, and it's going to help you in the future. So if you get it, that's perfect. So you start at one of the dots, and then you go to the next dot. How'd you do it? You do something called rise over run. You went up 1, so I'm going to put 1 on the top. And then we went to the right, 1. So your slope is 1 over 1, okay? So we go up 1, right 1, up 1, right 1, get a dot, up 1, right 1, there's a dot, up 1, right 1, there's going to be a dot, up 1, right 1, there's going to be a dot, okay? That's the slope. And for some reason in math, they like to use the letter M to represent slope. Okay, I don't know why, but I'm sure you can Google it. Okay, this next one. Does this show a proportional relationship? So let's go ahead and do our y divided by x to find if there exists a unit rate. When you go 6 divided by 0, it's not going to work because you can't divide it by 0. You can't divide by 0. See, it says error. So we'll go 9 divided by 3, which is 3. 12 divided by 6, which is 2. And I'm just going to kind of stop you right there. As long as you're very confident that you didn't screw up with right here with your division, then you should know, yeah, that's not going to be proportional because there's already a mismatched relationship right there. So this does not show a proportional relationship. No. Y is not proportional to x. Okay, because there's no unit rate. Now, let's go ahead and graph that. Okay, now if this was an assessment and you only went this far, I would recommend going down the rest of them, finding the possible unit rate there, just in case you did mess up. But I'm pretty confident that 12 divided by 6 is 2, 9 divided by 3 is 3. So I know that there's already not a constant proportionality existing. Okay, let's go ahead and plot these points. 0, 6, 3, 9, 6, 12, 9, 15, 12, 18. Okay. Okay, this one also appears to be linear, but since it does not pass through the origin, it's not going to be proportional, just like this graph tells us it's not proportional, okay? I mean, not graph, this table, because this table is not proportional, this graph is not going to be proportional. So, similar to the above problem, even though the graph is linear, it doesn't pass through the origin, so it's not proportional. So I can say that about this graph and this graph right here. But I do want you to find the slope, okay? Be very careful with what you're rising and running by. Try to find the slope. So I'm going to find the slope, and which means slope. Okay, pick a dot and get to the next dot, okay? So I'm going to go up, not 1, it's 2, because from 6 to 8 it's 2, so up 2. But we're not to the level with that, so I have to go up 3, because it's in between, to up 3, so on the top it's going to be 3. To the right, this is counting by 1, so we're good. 1, 2, 3. Okay, up 1, 2, 3, to the right, 1, 2, 3. Up 1, notice I'm going halfway. 1, 2, 3, to the right, 1, 2, 3. Up 1, 2, 3, to the right 1, 2, 3. So my slope is 3/3, 3 over 3. Or I could also say from this dot to this dot, up 1, I'm counting between, 2, 3, 4, 5, 6. To the right, these are counted by ones, 1, 2, 3, 4, 5, 6. Oh. Let's try going from this dot all the way to this dot. I'm going to count in between, okay? Because it's, it's counting by twos, but I'm going to look in between. So up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hold on, did I count right? Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What do these all simplify down to? 1 over 1. So yeah, this is a slope. Up 1 to the right 1. Up 1 to the right 1. Okay? So that's kind of the cool thing about slope. If it's all going to simplify down to the same exact fraction or number, no matter which two dots you pick. I like to start with a dot further to the left and make it to a dot further to the right. Okay, but more on slope later. I just wanted to give you a preview of it. All right, this next table. Go ahead right now. You should pause the video and determine if you can see if the money received is proportional to the candy sold. You can look at the table, use the table to help you, and then plot those points, okay? So y divided by x to find the unit rate. So I'm going to go 1.5 divided by 2. 1.5 divided by 2 is 75 hundredths. 3 divided by 4, 3/4 is 75 hundredths. So far so good for proportionality, but you want to check them all just in case there's an oddball, okay? 6 divided by 8. Same thing. 9/12. 9/12 simplifies down to 3/4. 3 divided by 4 is 75 hundredths. So yeah, this is a proportional table. Is the money received proportional to candy sold? Yes. There's a constant proportionality. Okay. What is the unit rate? Well, I know you're going to be like, oh, it's 0.75, but since there's a context up here, I want us to label everything because there's a context. It doesn't just say x and y. So you can pick, since we know this is a proportional table, you can pick any two values of x and y that correspond to each other to label and determine your unit rate. So I don't care. We'll go 9/12. 9 over 12. So it's $9 over 12 candy bars sold. And that would be, we want 1 in the denominator. And we got to divide by 12, divide by 12. 9 divided by 12 is 75 hundredths, so 75 cents per candy bar sold. I'm going to draw an arrow because I did not allow enough room right there. And that bottom number, the denominator, stands for candy bar sold, okay? That's an arrow. Okay, 75 cents per candy bar sold. What does the 0.43 mean? So 43, that means when you sell 4 candy bars, they receive $3. For candy bars. They'll receive $3. You'll receive $3. Okay, so before even graphing this, because the table is proportional, you know that this graph is going to be linear and go through the origin. Okay, so let's go ahead and plot those points. I do like putting it in this format just because I know that's what you're used to seeing. So that's why I've been doing that. If you can already plot it without that, that's fine. 2, x is 2, y is 1.5. X is 4, y is 3, 8, 6, 12, 9. Okay, let's go ahead and, well, hold on. So in this particular instance right here, can you sell like a fraction of a candy bar, like 0.5 of a candy bar? You can't. So I'm not gonna, it wouldn't be really accurate to connect the dots to reflect what's going on in the table, simply because this right here would be discrete. What discrete means is you don't connect the dots because you can't buy like half a candy bar, okay? Up here, there was no context, so you see it was like, oh yeah, duh, connect the dots. No context, so yeah, connect the dots. Right here, since we can't sell or buy a fraction or a decimal worth of a candy bar, that's why we don't technically need to connect the dots for this representation. But you can see right here that, yeah, it's going to be linear. It's because it makes a straight line and it's going to pass through the origin, okay? But I'm not connecting the dots because this is discrete. This is a discrete graph because you can't buy a fractional piece of a candy bar. Okay, think of that context. All right. Since it is linear, you could totally figure out the slope, okay? So I'm going to help you go ahead and do that, even though it's not really required. I just want to teach you ahead. So remember, M stands for slope. So you pick a dot, and then you make it to the next dot. So I'm just going to pick just this dot and go to that dot. I like to pick one further to the left and go to one further to the right. Go rise over run. So rising over running. So I'm going to go up. These are counted by ones. Up 1, 2, 3. So top number is going to be 3. And to the right, it's counting by ones. 1, 2, 3, 4. Okay, if I go from this dot to this dot, you know it's going to simplify to the same number. So I'm going to go up 1, 2, 3, 4, 5, 6. To the right, 1, 2, 3, 4, 5, 6, 7, 8. What does 6/8 simplify to? So let's go ahead and divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. See, so those would be both acceptable for slope. But we typically like when it's more simplified. Okay, go ahead and turn the page. So what are the characteristics of a proportional graph? Well, there are two characteristics that have to happen for it to be a proportional graph. It has to be linear. Okay, it's got to be a straight line, okay? And it has to pass through the origin. And you know the point for the origin is 0, 0. Okay, it's got to be linear and pass through the origin for it to be a proportional graph. If it's not linear, then it's not going to be proportional. If it's not going to pass through the origin, it's not going to be proportional. It's got to be both, okay? Both for it to be a proportional graph, all right? Okay, so you'll see there's no table here. You're just going to go right off the graph. In this situation is extra credit. So extra credit proportional to the number of problems solved. So you see right here, that's not going to be proportional. Nope. It's not linear. You're like, wow, it passed through the origin, but since it's not linear, it's not going to be proportional, okay? Okay, let's see this one. Does this graph display a proportional relationship between money donated and donations matched by benefactors? So let's see here. Is it linear? Yep. Does it pass through the origin? Yep. This is proportional. Yes. It's a proportional relationship. I'm going to abbreviate that for proportional. What's the unit rate? Okay. Here's where it could get a little bit tricky for you folks because you don't have a table. But that's completely fine because remember, the points in a table are directly, like, you can see them directly in the graph. So what you can do is, I know that point is 0, 0. This point right here is x is 200, y is 100. Okay, so x is 200, y is 100. This point right here is 400, comma 200. This point right here is 600, oh, I don't know why I put a comma there, sorry. 600, 300. This point right here is 800, 400. This point right there is 1,000, 500, comma 500. Okay. So to find the unit rate, since we know this is already a proportional graph, we just go y divided by x. And you can, since it's a proportional graph, you can pick out any one of those values that mean the most to you. Doesn't matter. So we got to go y divided by x to find our unit rate, and pick any one you want. I'm going to go with this one. Okay. So this is x. This is the x value. This was the y value. So I got to go 200 divided by 400. Since there is a context within the problem, that 200 right there is the donations made by the benefactor. And then that right here is the money donated. Okay, so to find the unit rate, we got one. We need to have 1 in the denominator. So 400 divided by 400 gives you 1, so I have to divide by 400. And 200 divided by 400. So 200 divided by 400 is 5/10. Okay. So for every $1 donated, the benefactor matches 50 cents of it. Every $1 donated, the benefactor matches, I guess, 50 cents worth of it. Okay, whenever it's linear, you can find the slope. So the slope for this particular graph, whenever it's linear, you can find the slope. It's we went up 100, to the right 200. Okay, up 100 to the right 200. So let's simplify this all the way down. Divide by 100, divide by 100. 100 divided by 100 is 1. 200 divided by 100 is 2. So my slope is 1/2. Simplified all the way down. So basically you go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Okay, and you'll get the points on the graph. And with a line, all these are points so close together that they form a line. Okay, but more on that later. Okay, look at this graph right here. Is admission price proportional to age? No. No. Even though it's linear, we can't determine, I mean, even though it's linear, it's not going to be proportional because it's not going to pass through the origin. It's linear, but does not pass through 0, 0, so it's not proportional. So is the graph linear? Yep. Hey, look, since I told you that whenever a graph is linear, you could totally figure out the slope. Okay, so we're gonna go, we don't go up 1, we don't go up 1. So we go up 0 to the right 1. Up 0 to right 1. So our slope is 0 for this graph right there. Okay, bye.